Hey, it's Random Code here, and today we're going to continue with Advent of Code, and we are now at day 7. And day 7 seems to be relatively simple, but I definitely overcomplicated my solution. But it is a simpler version of poker, where we get some kind of card inputs, and we then simply need to order them based on their value, where the best is 5 of a kind, 4 of a kind, full house, 3 of a kind, 2 pair, 1 pair, and then the highest card. So we have these rules, and we then simply have a bunch of card hands, and we then need to order them, and then based on the order, for the first hand we then say the value times 1 plus the second hand's value times 2, and so on. Then we get a value, and we then input it here and here. So I thought it would be just simple to quickly just do some fun little regex checks, just to, for each hand type, check the regex, then find it, and then compare them. It works, but it's definitely a bit overcomplicated. But it then makes like the main functionality very simple, because I just simply read in my data, and in my input we have these card values and some value for the specific hand. Read them in, put them into a map of cards and my value, and I then simply use a comparator. So I create a class and then utilize that Java can actually sort list if we have a way of defining how it's going to be sorted. So I create this comparator, and then very simply just take my map and turn it into a list of map entries sorted by the key from this map. And then all the functionality is then in my card set comparator, which ended up being quite large, even though it's actually very simple, but it's just a lot of code. We then have regex check to check all the scenarios. So first we check, is a card set, or does a card set contain a pair? Using regex, does it contain 3 of a kind? Does it contain 4 of a kind? Does it contain 5 of a kind? Does it contain full house? Then for some of these, I'm sorting the list first to make it a bit simpler. We have the sorting order. And then the simple explanation is that we simply just go through all the scenarios. We're looking at 2 cards. Simply check if one of the cards are 5 of the kind and the other is not, then we know the sorting order. If they are both either 5 of a kind or not 5 of a kind, we just keep going. And if they're both the same type, then for the same first scenario here, they're both going to have the same types for all of them. So if they're 5 of a kind, they're also both going to be 4 of a kind, 3 of a kind, 2 pair, full house, and pair. So in the end, it's just going to come down to high card, where we just simply go by index. So first look at the first index, which have the highest card. And if they have the same card, we just keep going through the indexes of cards. So relatively simple. We have this list of comparators. We just go through all of them. But then again, we both have the regex check set up, and we then have a mapping checking based on the regex check on each card, a boolean compare check. So there's a lot of code for something relatively simple. And I've seen some other solutions where you actually just kind of calculating which is better one by one, it seems, instead of have this almost insanely large comparator setup. But it's quite fast because we're utilizing Java comparators. So it's actually very fast, but there's a lot of code for doing something relatively simple. But that is kind of the structure of the first. So we have regex check to check the card is a type. Then we compare the 2 types. They're the same type, just keep going down the list. And if they're going to be the same type, they're going to have the same types for all the rest of the types. We're then going to compare by high card. And if we then run it, today I'm actually printing the full sorted list. We can now see here that then we have these 5 of a kind, one of them, which is like the most valuable. And then we just go down, and if they are both 4 of a kind, we then first look at the first one, same. And then in the end, the last digit, which is different, because this is then higher, this is more valuable than this one, and it's then placed later. For the second part, to make it a bit more complicated, J is then changed into a joker. So now hands can have like multiple scenarios. Now we need to, instead of just assuming the hand is what it is, the J can kind of be anything. And it's actually not too complicated for this setup. So I create a new comparator. I just simply, but I changed all my regex checks to now be either symbol for pair, take the first digit, then the second digit can be either the same as the first digit or a joker. And because we're then sorting first, the joker is always going to be to the right. So this would work because we might have a scenario where we have joker first and then an ace, for example. This would fail if it's not sorted, but because joker have the least value, is the least valuable card, is always going to be sorted to the right. So it's always going to be ace joker, which should match as a pair. But this then also caused another problem. It caused a few problems, but that's like one of the main problems. We need to sort before looking at our pairs, our full house, and so on. And we need to add all these joker checks all over. And we then also need to assure, because now, where previously, where if combination were 4 of a kind, for example, they would have all the same results for the rest of them. But because we have the jokers now, you might have a scenario where they are both 4 of a kind, but one of them is also a full house. So we actually do not end up hitting the high card comparator, which we should when they're the same type, meaning we get some wrong orders. So now an extra layer have been added where we before just checked, is one of them better? If they're not, just keep going down the list. We now need to check if they're the same, then either if they are both 4 of a kind, use the high card comparator, otherwise just keep going down the list. And we need to do it for some of them, but not all of them. And at the end, it ended up being a bit trial of error. I ended up just kind of finding a solution that works. So I'm actually not 100% sure this works for all edge cases, but I think it would work for most. It at least work for all my cases, so I get the correct result. And we can then also run 2. Again, in here, everything is the same. Extracting data, creating a map of cards to values. Then now using the Joker comparator, sorting a list of entries. And at the end, again, we get a sorted list, but now we can see it's a bit different because now we have, for example, ace, 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 joker, joker, which is now also a 5 of a kind, and then being the best 5 of a kind because we have aces in the first position. But this was my take of Advent of Code Day 7, and I definitely think this is not the best solution. It runs relatively fast because we kind of like using Java comparators to sort everything. So we just need to define how it's sorted. We not need to care about how it's actually sorting it. That should be optimized by Java. So from that perspective, it's kind of good, but we have these huge comparators which could have a lot of smaller errors and things that we actually might forget. So not the best solution, but it works. But otherwise, if you enjoyed this showcase of Advent of Code Day 7, please leave a like and subscribe, and I wish you all a wonderful